Okay, in 4.1, number 5, we're given this function, f of x equals negative 4x squared minus 8x plus 15. And then we have 3 parts. And this is a parabola. Remember, this is a quadratic, which gives us a parabola. And it looks like it's a parabola open down. So it's asked us to find the vertex is the first thing we're asked to do. And there is a quick way to do this, and this is using, it will find the x value of the vertex by using this negative b over t 2a, and then once I find the x value, I can plug it in and find the y value, or the f of x value. So my a comes from here, negative 4, and my b is my what's ever in front of my x variable. The x squared is my a, that's my coefficient, and the coefficient in front of that is my 8. And we're going to plug these in. So negative 8 over 2 times a, which is negative 4. So it looks like I have 8 over negative 8, which gives me negative 1. So I have a negative 1 for the x coordinate of my vertex. And in order to find the y, or f of negative 1, I'm going to plug negative 1 in to this quadratic that we're given. So f of negative 1 equals negative 4 times negative 1 squared minus 8 times negative 1 plus 15. And I get negative 4. Well, negative 1 times negative 1 is 1. Negative and a negative gives me a positive 8 plus 15. I have negative 4 plus 8 plus 15. Well, negative 4 plus 8 is 4 plus 15. So it looks like I get 19. So my vertex is negative 1, 19. Okay, so the next question, or the B question, let me slide this up a little bit. Okay, and it's asked us to find the vertical intercept at this point. So the vertical intercept would be the line that goes vertically through this point, and that's going to be x equals negative 1. Because think about it, if you graph this, this is the vertex. The vertical intercept is going to go through that point. It's a vertical line. Okay, so it's got to go through this x value in order to be a vertical. Actually, it's the line of symmetry is what we call that, because they happen to be calling it the vertical intercept. Vertical intercept, and this would be the same as the line of symmetry for this parabola, because if you remember from a parabola that they have a line of symmetry which goes through them, and you can fold them in half by that line, and you're going to have the same thing on both sides. And there actually should be 2 m's in symmetry. There we go. Let me spell that a little better. Line of symmetry. There we go. So anyway, 2 m's in symmetry. And let's see. The C question asked us to find the coordinates of the 2 x-intercepts of the parabola and write them as a list separated by commas. So actually C wants us to find slide this up a little bit. The 2 x-intercepts. 2 x-intercepts. And if you've graphed this, again, it's open down with a vertex of this, so they're going to cross the x-intercepts. So in order to find the x-intercepts, remember that's where y equals 0. So we'll have 2 of them, where y equals 0. So we need to figure out what those x values are. So we had negative 4x squared minus 8x plus 15 equals 0. So we set the f of x equal to 0. And just because I don't like working with a negative here, I'm going to multiply this whole thing by -1. So it's going to change the sign of all of our terms. Now I'm going to factor. Or you use, if it's not factorable, we could use the quadratic formula in order to solve this, just depending on what you want to do. We can try trial and error factoring. We can use the box method again, which I think I will, to see if it will work, if it is factorable. And you remember you put the first term, and then we have the last term, and we know we're going to have an x and an x. -15 times 4x squared is going to give us a -60x squared, and we need to find the factor pairs of 60 or -60, and which one of those are going to give us an 8, which is our middle term. So let's take a look at that. And again, plus or minus 1 times plus or minus 60 plus or minus 2 times plus or minus 30 plus or minus 3 times plus or minus 20. And we're still trying to get to where this is going to be give us an 8, or where we could add or subtract and get an 8. We're not quite there yet. Plus or minus 4 times plus or minus 15. Well, we're getting close. That would give us 11, but not quite 8. What about 5? Plus or minus 5 plus or minus, let's see, is it 12 would give us 60? Yes. That would be, well, if it was 7, we would be good because we're not getting 8. Well, what about 6? Plus or minus 6 times plus or minus 10. That still is not going to give us an 8. And we could try, will 7 go into 60? And we could try, let me slide this up a little more, 7, 8. Of course, we already did 10, and none of those are going to give us a pair that will, it will multiply and give us a -60, but not add or subtract to give us an 8. So that's a problem there. So this is not factorable. So when something's not factorable, we have to use the quadratic formula. And sometimes you just have to work it out to see if it is factorable. Okay, so let's try using the quadratic formula to solve this. And remember what our quadratic formula is. X equals -b square root. Let's see if I can get this focus in a little better. B squared minus 4ac all over 2a. And we're working with -4x squared minus 8x plus 15. I need to know my a, b, and c. -4, -8, and a positive 15. So let's plug in what we have. X equals -b plus or minus -8 squared. That's my b. Let's see if I get this to come in. It keeps wanting to go out of focus on me. Minus 4 times -4 times 15. Okay, so I'm just plugging in my a, my c, all over 2 times a. Okay, and now we just need to, negative and a negative is a positive. Square root, -8 times -8 is 64. Negative on negative is going to give me a positive. And let's see, I'm going to use my calculator. 16 times 15 is 4 times 4. It looks like that's 240. That's all over negative 8. And then 240 plus 64 is 304. So x equals 8 plus or minus square root of 304 over negative 8. And we can see if 304 is a perfect square. I don't believe so, but you can use your calculator to kind of look that up. And it's not, but can we break 304 down into something that maybe is a perfect square? And so you could start by trying some different numbers. For example, I'm just looking at this 304, and I can break that down into 16 times 19. And sometimes you just have to play around with these and see if you can break it down into something that's a perfect square. This works out nicely because that becomes 4, because the square root of 16 is 4. 19 is not, so it's just going to be 4 square root of 19. So I'm going to bring this back over here. Don't want to lose anything. X equals 8 plus or minus 4 square root of 19 all over negative 8. And we can simplify this a little more. I'm going to break it into two fractions. 8 over negative 8 plus or minus 4 square root of 19 over negative 8. Because 8 over negative 8, that's going to be a negative 1, plus or minus. Looks like 4 will go into 8 twice, 2 times there. So I get square root of 19 over, and I really don't, I can put that negative 2 there. However, this plus or minus is really going to either make it a positive or a negative, so that really takes care of that negative 2. Now just really depending on how the answer is wanted, if it's if we can round it, then I'll probably go ahead and use my calculator. I could have used it at any point. Well, let me see if I can bring it up here. Okay, because I believe the instructions say round to 2 decimal places, so I think we can do that using our TI here. All right, let me turn it on. And there's a graph actually of this. And I can do negative 1 plus the square root of 19 divided by 2. Now you notice I closed that parenthesis because 2 is not under the square root. And it looks like I get, let's say, round to 2 decimal places, 1.18. Okay. And then I'm going to do the same thing, except it's going to be negative 1 minus the square root of 19 divided by 2. Divided by 2. And let's see, it looks like I get negative 3.18. Okay, so let me move this out of the way now. So again, here's our 2 answers that I actually can plug back in over here. Since it wasn't factorable, this did not work for us. This did not work. But using the quadratic formula, I came up with 1.18 as one of my x-intercepts, and then negative 3.18 as one of my x-intercepts for this problem. So that did take a little bit to work through that one. Sometimes factoring does not work. Sometimes you do have to use a quadratic formula, or you could use it to start with if that makes it just go quicker. Possibly could. And since the question said we could round these, let's go ahead and go back to that graph. So again, we're looking at the graph, and we can actually find these Again, it won't give us the exact answer, but since we could round it, I'm going to go to second trace, and we're going to calc. We'll do it in a second. And I want to know what my zeros are. Go down to number 2. And I'm going to go over and let's look at this side. And it wants us to find the left bound. So again, we're going left to right. So this would be the left bound for this particular side, because I want to know what that 0 is. Enter. It wants the right bound. And then guess. Well, that's pretty close. Enter. And as you can see, I get negative 3.179449. Hey, that's what we came up with. All right, let's do it again, except let's do this side. So I'm going to go back to second, and we're going to calc. And I want to know the number 2, which is 0. And then let's find the left bound. Left bound. And right bound. And yeah, that's about as close as we're going to get. Enter. And as you can see, I get the 1.17944, and that's my 1.18 rounded 2 decimal places. So again, once it said it was rounded, I could have just used my calculator to find those 2 zeros.